Next Curve.
Hey, welcome to this Next Curve Rethink podcast episode where we break down the latest tech and industry events and incidents and happenings into the insights that matter. And I'm Leonard Lee, executive analyst at Next Curve. And in this Silicon Futures episode, we will be talking about a lot of stuff, mainly the month of November and all the exciting things that have happened in the world of semiconductors. And I am joined by my wonderfully fabulous friends in the industry analyst community, two individuals who I regard very highly. Karl Freund of Cambrian-AI research, and the equally fantabulous Jim McGregor of the famed TIRIAS research group. And how are you gentlemen doing? It feels like an eternity.
I'm rethinking your terminology now.
Oh, really? Fantabulous? I have the best words.
Fantabulous is a great word. Yeah.
I have the best words. So how are you gentlemen doing?
Doing good.
Doing good. Happy to be here, buddy.
Yeah. Okay. Awesome. So before we get started, remember to like, share, and comment on this episode, and also follow us at www.next-curve.com. Also, you'll find us on YouTube and Buzzsprout here every month. So I'm doing this with Karl and Jim, and we're just trying to bring the latest, greatest, and hottest topics in the semiconductor industry. And so join us every month, and you will be in the know. So with that, November, crazy month. I mean, I think almost every single month is a crazy month in the world of semis. What do you guys think? What did you intend, first off? Because this is like the high season for events, but maybe Jim, let's start with you.
I didn't intend as many things as I expected because I was ill, but my colleagues did. So, I mean, there was a lot of things from the end of October through November, from OCP to SC24, IBM's Quantum Developer Conference, Microsoft Ignite, on and on and on. Just so many things and so many announcements. And, and a lot of announcements, not just about semiconductors, but really about systems and systems architecture as well.
Yeah.
So really impressive. Even EDA tools, seeing announcements by companies like Siemens about their new across-the-board UI that uses AI. So there were tons of announcements to discuss.
Yeah. So any particular ones that you want to highlight, or do we pass the ball on to Karl and give him a chance to just...
Let's go. The first thing I'd like to highlight. Well, no, let's go into Karl, and then let's go because we have so many things to discuss.
Like you, Jim, I got a little bit ill this month, but other than that, I was able to attend a few events, either virtually or in person. I think your comment about systems is sort of the highlight of the month. If you look at, obviously, supercomputing is all about systems. Nobody cares about the chips. Well, they care. What they buy is systems. Obviously, AMD was riding high from their turning on El Capitan, and
that's right.
And that was a big deal. It was a big deal. When I think about that, it's like, well, how did NVIDIA drop the ball there? And I was at AMD while those chips were being designed. The focus was really on winning DOE's love and attention and money. And therefore, they really focus on 64-bit float. And yeah, it has decent AI performance too. But their priorities were HPC, and then AI. And you look at NVIDIA, their focus was AI, and AI. And so as a result, you're seeing the demonstration of the prowess of AMD and HPC, but also the prowess of NVIDIA really cementing their lead in AI. I'm not hearing a lot of people talking about MI300s anymore. I'm sure they are. They're not talking to me about it, though. Mm-hmm. And with the focus really being on Blackwell. So right. I think it's not that one company screwed up and the other one didn't. It's really they had different strategies. And you're seeing that playing out in their silicon, and we'll see where that goes with their roadmaps.
Well, and also, especially for the DOE and these labs like, Frontier and El Capitan, these supercomputers, they were focused on the system. They were focused on a massive supercomputer. And to that point, AMD was offering the complete system solutions. They were offering the processors, the accelerators, the DPUs. They were offering all that. And it really hasn't been till recently that we saw that come from NVIDIA, especially with Grace. Grace is now proving its worth. And we've seen a lot of system innovation from them, but just recently, and that's through the GB200 with the Blackwell generation. So yeah, I would agree with you. And people have to remember that a lot of these systems, just like semiconductors, they were planned 4 or 5 years ago. So, a lot of decisions were made years and years ago. That's why they're not even on some of the latest technology at this point in time.
Yeah, and the other interesting topic that keeps coming up lately are these discussions around scaling laws. We're hearing it all across the board, and one of the interesting things that I'm noting is as we start to see these comparisons across the HPC universe, like what you're talking about, Karl, HPC versus quote unquote AI supercomputing, the data type, right? And in one corner, you have HPC where, like you mentioned, you have 64-bit float and then 64-bit, and then you have what you have NVIDIA talking about quite a bit, and the rest of the generative AI supercomputing universe, the 4-bit, right? Yeah, but they try to compare each other using these two different data types, right? And it's not a fair comparison, right? It really isn't. But then it's causing a lot of confusion, I think, in the marketplace, where you have one side claiming, oh, we have leadership in supercomputing. It's like, whoa, wait a minute. Well, if we apply 64 over here, you're not scaling as quickly as you might be asserting. But there's now increasing confusion around scale, whatever people are referring to as scaling laws. But that's something that I noticed in a lot of the events that I've been attending, where you're hearing a lot about scaling. I mean, it's literally prefaced in many of the keynotes that we're hearing, and most recently at Microsoft Ignite. So, yeah. But this is, I think this is going to be kind of like a semantic shakedown that's going to happen over the next 6 months, right? As I think there's going to be a system level bid for diversity, right? Making these system investments more multi-purpose. So let's say not just for AI, but for all the other kind of supercomputing, especially off of this idea of general purpose accelerated computing.
Yeah, well, NVIDIA is trying to do that, obviously, with supporting not just AI workloads, but also RAN workloads. So for the wireless networks, and obviously they have an announcement there with SoftBank. So I would agree with that. I would also agree that, and we've seen this from Jensen, we've seen this from Pat, Gelsinger, say that, the new unit of compute is the data center. And really, the biggest thing is you have to start building these solutions at the building level. And then, and then going all the way down through the infrastructure, through the network, through the chipsets, or through the solutions you select. And we're seeing this. Now we have AMD and NVIDIA, or AMD and Intel offering different types of CPUs. So you may use different types of CPUs in the data center. You may use different types of accelerators. One for inference, one for training, one for HPC. And definitely DPU for offloading some of the overhead workloads. And networking, networking is becoming so critical, to be able to handle this, not to mention the memory bandwidth. So it really becomes especially for the data center, it becomes a building level challenge.
Yeah, I think you're exactly right. And this is why we see NVIDIA putting more and more emphasis on their networking, whether it's NVLink or InfiniBand or their version of Ethernet. They're focusing a lot of attention on that because that's the bottleneck now. And I think that the power constraints is the next bottleneck. And then you get to memory, and then you get to the actual performance of the chips. And so when you think about it from a data center level, it kind of flips everything on its head as to what the priorities are. And new players will emerge, whether they're doing new networking topologies, like one of my favorite startups I'm interested in called in Fabrica, which is doing for the back end what NVLink does to the front end. So I think we're going to see a real shift because of what you're talking about, Jim, as everybody gets more and more focused on data center scale.
I don't know why I put on do not disturb. And anyway,
that's okay. We disturbed him.
Yeah,
he's disturbed.
So much for Apple Intelligence. There's one ding on.
I haven't found it yet. My whole room's full of Macs here, and I haven't found Apple Intelligence yet.
No, I haven't either. So, which was one of the big releases of November, or at least the tail end of October. Yeah, I mean, I have to really be honest here. I'm not all that impressed. But then, we have to remember they call it a beta, right? They're not saying that as, hey, this stuff is ready. I mean, officially, we're supposed to treat this like a beta, right? And so there's going to be limitations, and they're doing this progressive rollout of features, which is probably smart, quite honestly. But I'm just not finding it as useful and helpful as
just like Copilot.
No comment. Yeah. So. Yeah. And so what, I know a couple of things that I attended, Qualcomm Investor Day. I was there. I know you gentlemen weren't able to make it, unfortunately, because you're ill, but I thought the key takes there for me were this push toward the growth markets, right? And it literally emphasized only that. They didn't really talk about mobile much at all. QTL, almost no mention. It was all about automotive, where they continued to make traction, especially with connectivity and most prominently infotainment. And they're making a bid toward, really tapping into this whole ADAS market, not autonomous.
Yeah, with BMW,
which I always thought was really smart because, with the autonomous stuff, it's niche and your sights are too far out in the horizon. We've seen what's happened with a lot of companies that have been orienting themselves toward more the, let's say, SAE level 4 to 5. They've had to throttle stuff back toward 3 and 2.5, right? Yeah. So
AT&T seem to solve a lot of the customers' needs right now. I'm not sure customers are really ready to trust 4 and 5. So I think that what they're doing is very smart. In fact, if I could just predict, I would say they'll overachieve on their automotive. The one I'm more worried about is the PC, where they've got a good chip, but that's a tough ecosystem to crank into and produce. I think it's what, $4 billion in revenue.
Yeah,
which is probably 10 to 12% of the market by 2029.
Yeah, that's a lot.
Yeah,
and I agree with you. I think they have a great strategy for automotive. Being the dominant player in telematics, becoming a dominant player in infotainment. Definitely, you'd be foolish not to look at them for the command and control systems, for the ADAS systems, if you're already using them throughout other parts of the vehicle.
Yeah, absolutely.
How do you think that'll shake out, Jim? Do you think that they'll end up owning the bulk, or if anybody owns the bulk, of being a market leader in infotainment, and somebody like NVIDIA will take care of the heavy lifting of ADAS? Do you think that where are the OEMs going?
The funny thing is the OEMs, from what the ones we've talked to, they're all hedging their bets. They're working with multiple partners. They're working on their own solutions. Matter of fact, if you go to a tier 1 like Continental, they'll say, okay, here's our command and control box. What would you like in there? Would you like a Qualcomm board? Would you like an NVIDIA board? Would you like, the same box? So even they're hedging their bets. But no, I think it will, a lot of it's going to come down to the software. And really having because we keep calling it the software-defined vehicle, and having that integrated software solution, but still being able to customize and control it, because nobody wants to give up control of the vehicle to Apple or Google. So I think having that software, that unified software platform, is going to be critical. They don't have the training solution. So if you're going to train today, you still got to go use NVIDIA. But I think having that unified software solution is going to give Qualcomm an edge up.
Yeah, but I think that's where this whole, they didn't talk about it a lot, but the whole one technology roadmap strategy is important. And I think AI Hub is taking on a more prominent role in fostering that strategy on the AI front, right? And so as you look at them take, like, for instance, Nakul always talks about chassis. He loves chassis, right? Now, taking that to the industrial IoT, I mean, the whole idea is how do we make all of these assets that we have that are optimized for the Qualcomm stack and port them over into different domains and growth market, and which end up being the growth markets that they're targeting. How do we create that technological synergy and portability that brings the optimized goodness that they have? And I think they have a great starting point with automotive, just because they've had to build safety critical systems, and they have now an understanding of that, porting it over into industrial IoT, which is the other big sector that they want to diversify into, which they're bringing a chassis concept there. It's going to be interesting because industrial IoT is such a messy.
But let's face it, guys. If the U.S. auto, or I should say the Western auto manufacturers, can't figure out a way to produce cars more economically, they're all going to lose to China. So it's not going to matter.
Yeah,
that's absolutely. And China seems to know how to build electric vehicles too, don't they?
Yeah. Well, when you're subsidizing, 30 to 50% of the cost, it's a little bit easier.
But we also have to get off of that. Because at the end of the day, we need to, like the Western companies need to figure out how to compete.
Yeah, they do.
Because we've seen this play out before. And it never, if you focus too much on what you might deem uncompetitive, it distracts you from actually innovating and then figuring out a better way of competing. And that's what really frustrates me when we have people, focus too much on, they're subsidizing XYZ. It's like, no, but how are you going to figure your stuff out? Because, the CHIPS Act, that was the other thing that it's a big news item. Just, I think it was today, is there's this rumor or report from Reuters that Intel might be getting less love from the CHIPS Act than originally anticipated. But, this focus on subsidies here in the United States, rather than having that solid plan of competing without the subsidies,
and tariffs,
which end up being much smaller in terms of the investment that's required. How has that benefited the industry?
It worked out so well for the solar industry.
There you go. But hey, you know what? I'm really curious. So SC 2024, I wasn't there. I didn't even listen in on any of the stuff. So any cool takeaways or highlights from that event?
There were a lot of announcements, obviously, about new supercomputers and everything else. AMD taking kind of the lead spot on in the top 100. And, also taking the lead spot, now going from Frontier to El Capitan. And there were other announcements. NVIDIA made a bunch of announcements around some of its new NIMs and models that are available and some of the solutions. And quite honestly, anybody that thinks NVIDIA's Moat is just its hardware is foolish, because their software strategy is really their strength at this point.
Yeah, I think people fall into the trap that their moat is CUDA. It's like, no, that's at the bottom of the moat, right? And all the water on top of that is all the other software they're putting on top of CUDA, which drags CUDA along. Yeah. But I'm reminded of a conference I was at recently where a second-tier cloud provider basically said that, actually was a first-tier cloud provider. He was now at a second tier. So I won't tell you who it was, but they were saying their management came and said, you had to start using our chip. And the team said, fine, we won't make schedule. We won't deliver on our performance goals because we've got to spend all our time on the software.
Yeah.
Right. And so their software moat is deep and wide. And it's not just CUDA. People use the word CUDA. That's not it.
You're right. I mean, that is much lower level.
And I think SC24 was kind of a critical point. We're seeing a lot of transition over towards different forms of liquid cooling. Yeah. I'm still not a big fan of immersion. I did that in military applications. I think I can tell you all the problems with it. But no, also, we're on the cusp of having UA Link a UA link solution come out next year.
Really?
A universal Ethernet specification should be completed shortly or early next year. So we're going to have a lot of new networking
You're expecting
solutions
UA
coming
link to
out.
ship this. You're expecting UA link to ship this in 2025.
Well, actually, AMD's Polara actually supposedly supports the 1.0 specification for the Universal Ethernet Consortium. So you see. So yes, so a lot of that technology is coming out very, very quickly. So I mean, seeing the investment in the infrastructure, the investment in the networking, and continued investment just in supporting, scaling, as you pointed out, is a critical issue. Scaling solutions going forward and making it more economical. So
whatever scaling means these days. Seems like everyone keeps pivoting around all over the place. But that's actually probably a good topic of research and study. Clarify, what the hell do you mean by scaling? But I want to go back to the comment around names. It's interesting.
Just a quick comment for you. One of the things I've been looking at is, how do we make the entire thing more efficient? Because we tend to think, oh, well, we need to make the chips more efficient, or we need to make cooling more efficient. I've actually sat down with NVIDIA, Vertiv, and a couple of other companies, and the list I have is phenomenal. So it makes me very positive that we can achieve these not just 100x, but 1000x jumps in efficiency from generation to generation.
Yeah, I think the Information Week publishes their concerns about, or they reported that people can't install Blackwell because of heating, it's overheating and so forth. To me, that the point people should take away from that is that this stuff is not easy, and you need to pick the right partners, because if you pick the wrong cooling partner, of course it's going to overheat, right? You pick the wrong cooling solution, right? But if you pick the right cooling solution, Microsoft and Meta, they're standing up Blackwell just fine, thank you very much. So I think that system focus has got to be the theme, I think, for the next few years.
Yeah, and it's also important to identify now NVIDIA and now probably increasingly AMD that they're not just chip companies anymore. We've talked about it at this.
AMD's got
already previously on our podcast here, but they're building out entire systems, and you're making a great point, Karl. When you're delivering systems and you're working partners to just get customers to that the last half mile, there can be variances. That's where you're going to see the variances in the implementations, and you could be a partner that's not that great could be engineering problems into that system. It has nothing to do with the chip, right? So chip is way down there.
That's actually why I think Vertiv is one of the most interesting companies out there right now, because they supply that complete infrastructure to the data center. They've got the electrical solutions, they've got the cooling solutions, they've got the networking solutions. That's almost what you have to have. And obviously we're seeing Supermicro kind of go that way with their new group focused on data center design. That's almost what you have to do to be able to compete in this market, to be able to service, especially when you're dealing with data centers that were built, 5, 10, 15 years ago. How are you going to re-architect reuse those facilities? You have to have a partner that knows how to do that.
Yeah. And, I just want to throw a comment out there regarding NIMs. I think that's more of a quote unquote enterprise AI type of artifact.
That's all about
something that's really related to supercomputing. So it's interesting that you mentioned that, because if I was NVIDIA, I wouldn't really focus on that as much as I would the system and then the scaling part, right? Scaling these systems to whatever, 1 million GPUs in the next generation, and why that matters, and how that's going
I think they're focused on both.
Yeah.
Jensen said, Hopper's ending at 100,000. Blackwell's starting at 100,000 nodes, right? And I think that the cooling solutions are getting pretty creative, right? I don't know if you've seen this. Flex acquired a company called JetCool. And so instead of running fluid across the chip like this, they're actually injecting fluid down closer to the chip. And it's much more cost effective, much more effective in cooling. And so you're going to see a lot of more innovation in that space as people are not going to do is just say, well, I'll just buy air cooled for the foreseeable future. And everybody needs to be preparing for liquid cooling.
And it's funny you say that, because I also think that that's going to force a change in system design. Pretty much all the systems we use today are trays or pizza boxes, if you've been around long enough to hear that term.
Microsystems, yeah.
And when I was at Motorola, we did blade solutions. We did VME, compact PCI, advanced TCA. Exactly. But I mean, they were extremely dense. We even put fiber in the back planes for some of the high-end systems. They were really, really expensive, but they were really, really good. I'm just saying, I think that that's going to drive a whole innovation. And I've talked to some of these companies and saying, hey, have you taken another look at blades? Because you're working to a point where you need to think about the cooling and the power and everything else. And I'm looking at Blackwell and I'm like, I could have done that with blade systems so much more eloquently, without having 5,000 cables going back up and down the backplane as a backplane for it. But, it's going to be interesting because I think it's going to drive a lot of innovation.
Well, those 5,000 cables brings up another topic we should probably explore at a future broadcast like this. They're doing 5,000 cables you need the point-to-point connectivity to deliver the performance NVIDIA intends to deliver with Blackwell. That's all going to switch to optical. It's a question of when.
Yes.
And they talked about, well, we can't do it now. Gotcha. You can't do it now. Yeah. It's not cost effective now. But that's going to change. That's going to change in the next 3 years.
And once again, we did optical backplanes 20 years ago at Motorola. So it's feasible.
Yeah, it boils down to economics, right?
Yes.
Right.
Yeah. I mean, that's been sort of the gating factor. And one of the things that I think is becoming quite clear is whether or not you think GenAI has legs or not. It probably does. It may be shorter, maybe longer than what we think. But one of the things that's quite evident is all these innovations in supercomputing are going to be the things that stick, right? And what I'm really starting to see is how some of the paradigms that are happening up here are starting to trickle back down, and as people are starting to look at edge deployments. And so, Jim, you mentioned SoftBank and NVIDIA collaborating or having this. Actually, it's a new offering and architecture around AI RAN. That's a great example. I'm not in the camp that thinks that all of a sudden you throw a GPU out there, you can have like a GPU as a service business and it's all, net revenue. It's not. RAN is cost and your GPUs out there are cost. Monetization, that is a separate topic. And that is one of the things that have undermined a lot of conversations around emerging technologies and their potential for delivering economic value. The thing is they're separate. The GPUs are cost as well. And whatever you use to provide a service that is monetizable, that's still cost. And you still have to go through the profit equation, part of the equation. But yeah, it's exciting though to see how there's this influence coming down from generative AI, supercomputing, and all the innovations that are now, I think, finding better economic profiles. And that's something I think we should probably keep an eye out on as we're covering the industry, because I have a friggin' funny feeling a lot of the stuff is going to start showing up in on-prem and certain edge environments, as well as, stuff from the bottom up as well. A lot of it originating from mobile computing, right? So,
well, I always have 3 questions for companies. First question is how is AI going to change your company operationally? Second one is, how is AI going to change your products and services?
Yeah.
And the third one, and not many companies can answer this one, is how is AI going to change your business model? And what does your company look like in 5 to 10 years? And if they say it doesn't, I worry. Matter of fact, I asked that question directly of Jensen at GTC, and he looked at me and he says, Jim, I wish I knew. I love that answer.
Yeah. Well, it's interesting. I'm working with a couple of clients where I'm telling them, I don't know, or we'll find out is not a good enough answer. It really isn't.
It's not, but you have to at least realize that AI is going to change all three of those aspects. And if it isn't, you're not thinking big enough.
Well, yeah. Or you're not thinking clear enough as well. I ask this all the time because whether it's 5G, it's IoT or whatever. And to your point, Jim, a lot of times you hear, well, people will figure it out. It's like, no. People will not figure it out.
Well, people are going to figure it out. That means your competitors are going to figure it out before you. And I think a perfect example of what you're talking about there, Jim, is enterprise software market. Mm-hmm. The impact of chatbots on enterprise software is not much. The impact for AI agents on enterprise software is massive. Yeah. You can build the functionality you need. The AI agents can build the functionality you need using common software that's on everybody's Macs and PCs. Yeah. And that's going to change enterprise markets. So, everybody from SAP to Snowflake's got to figure this out.
And to be able to find efficiencies that traditional AI didn't find or that people didn't find, from the data that's already there.
Yeah. And, speaking of edge AI and taking this, across all these NPUs that are now proliferating across the enterprise edge, it's trying to figuring out how to get to good AI, because now, earlier in the year,
good AI. Is there good AI?
Oh, there's a lot of crap AI out there. Trust me, man. It's getting things out of the experimental stage in terms of the technology, as well as any kind of application architecture that your generative AI augmented solution is based off of. Because like Microsoft earlier this year at Build, they were talking about over-reliance, right? And this is kind of alluding to the challenges of quality of a lot of these agents, as well as generative AI models, right? Whether you use RAG or what have you. Now, what they introduced at Ignite this year was this term oversharing, which speaks to the security limitations of the entire stack. And this is something that I've written about for over a year and talked about for over a year. So as you look at edge AI and taking these large models that have been created through all this massive supercomputing, and you start to bring it down and try to figure out, okay, how do we deploy these things in a good, reliable, safe way? I think that's going to look a lot different than how people are thinking about it right now. Because right now we're thinking about, oh yeah, you drop a Copilot or you run all your stuff on device. Well, depends on what kind of data you are deploying on device and what you will be dependent on in terms of data in the rest of the organization and how you manage that. And so I think all those architectural decisions are going to have implications on where demand for compute is going to be, and what type of chips, right? And where processing storage will reside. And that's where I think edge AI is going to be a really, really funky, weird phenomenon to observe in the near future, because everyone needs to get there. Otherwise, no one's going to be able to pay for all this.
Especially with the use of agents, because you have to have, in a lot of cases, you may want traditional AI. Otherwise, you have to have some pretty strong guardrails for security, for operational management, for all these things for edge AI, where you could impact your operations, your customers' operations. You could impact safety, security, all these different things.
Yeah, and just like, since we're on a topic of Microsoft, they a couple of things on the silicon side. One of the things they introduced was the Azure integrated DPU for storage, right? So I thought that was interesting, because when we think of DPU, oftentimes we think in terms of processing offload, right, of networking workloads. But here we're seeing something a little bit more akin to, let's say, IPU, Intel's IPU type of concept, but for storage. So
it really depends on who you talk to, because I mean, it could be storage, it can be networking, it can be security, it can be even AI workloads. It can be, I mean, it's an overhead offload engine for the most part.
Yeah.
And it's funny because, we have them from Intel, we have them from NVIDIA, we have them from all the major semiconductor vendors, and they're all different. So,
but you know what? You know what's really weird though? You know what's weird? With all this talk about accelerated computing, you have all this offload, but it's to allow the CPU cores to do what they do best. And that doesn't seem to go away, which is like a funny thing about all of this, sort of accelerated computing offload compute talk. You know what I'm saying? And I don't know. I've been in a couple of conversations over the month where people are spelling the doom of the CPU. It's like, well, the world is more of an XPU kind of universe, and the CPU has its role, so anyway.
Well, exactly to your point, the CPU is morphing, just like, I even hesitate to call these GPUs in the data center because, let's face it, they're more of an accelerator than they are a graphics processing unit.
That's fine.
Yeah.
She talks about accelerated computing now.
Exactly. And the CPUs are going through the same change. I mean, we're seeing different SKUs, especially from Intel and AMD, for different types of workloads. They're integrating, or you look at IBM, they're integrating AI accelerators and some of this offload functionality into their processors. So I don't think the CPU ever goes away. I think it continues to morph like the rest of the architecture.
Yeah. But the thing though is NVIDIA will always, hey, look at our GPUs. But then what they really mean is this large, massive, logical, heterogeneous blob that does GenAI supercomputing wonderfully well at a massive scale, right?
It now includes their Grace CPU. Matter of fact,
Yes.
all three of the companies, NVIDIA, AMD, and Intel, have made the case that the performance of the CPU impacts the AI performance of the system over the past couple months.
Yeah, and Jensen's always said he needs top-end CPU to make his to make the GPU sing and dance, right? And so he couldn't get one to talk NVLink after IBM Power dropped it. So now he's building his own, primarily for NVLink, but also so he can do this fully integrated solution to not only today's AI, but for tomorrow's AI.
They should.
Investors ask me, so what is NVIDIA's secret sauce? And I said, it's their relationship with the researchers that are inventing the next thing. Right?
That's true.
They're sitting right next to each other. They're working hand in glove. And so they know what's coming next much better than the three of us do.
Well, and the Meta announcement was a key example of that. Meta has their own chipsets, but they're also working with NVIDIA. And the fact that they already have their own version of a GB200 system modified to their specifications.
Yeah, that's right. Yeah. So, I think they should brag about Grace a lot more than they do. Is my point,
Well, Jensen doesn't want the ick of CPUs. The ick of CPUs is low margin, right? And, his margins are well over 3 times what a CPU vendor can deliver. He doesn't want to be a CPU vendor. He wants to be a data center vendor.
Yeah. Well, that's probably what he needs to be identify NVIDIA with, because that's literally what they do more than anything else.
Yeah.
It's a revenue share, right, within their business. So, but any last comments or sharing that you gentlemen want to do?
Recipes for Thanksgiving?
Recipe? Well, ask Perplexity, apparently, right? Is that what your family is going to do this year, Carl?
Yeah. It's all based on Perplexity.
I would just end with this on my end, of the fact that from the enterprise or the user side, we're seeing continued investment in AI, anywhere from the mid-teens up into the 30s, and sometimes even 40% range in terms of implementing or using AI, whether it's their own implementation, whether it's using services and partners. So, I think the concept of the AI winter is nowhere near. I think that 2025 is going to shape up to be another huge innovative year as we go forward.
And I agree. The question that brings to mind is, where's all this money going to come from?
And
my theory is we're going to see an elongated shelf life of CPUs. So the normal refresh rate that we've seen for Intel and AMD CPUs, I'm not sure that's sustainable because money to fund all the AI has got to come from somewhere.
Yep.
That's the fastest way to fund all that research and development.
Yeah, I mean, I'll have to slightly beg to differ. I think 2025 is going to be a year where people discover what this technology can't do, because they imagine so much about what it can do. And so in my own research, mostly focused on end market and how companies above the stack are struggling to really monetize and help their customers find value in these technologies, largely due to reliability and safety issues. I think these POCs are highlighting what the limitations of the technologies are. That is something that people haven't discovered yet. And so once you get past that hump, then you're going to get onto that proverbial Gartner plateau of productivity. But before then, we're still in a hype cycle because people are, their expectations aren't set on, have their expectations and perspectives on the technology haven't quite yet been checked by ground truth, right?
But we're in the tech industry. We don't think of limitations
I know.
blocks or anything else. We don't think of what could go wrong. We just keep going forward.
See, that's what I love about, it's like 2 against 1, but I have the power, even though I never do it, to edit all of your stuff out. So that's what I love about you guys. Hey, that's all the time we have. I know that you guys have to jump, you guys have to bounce, but why don't you really quickly tell our audience how they can get in touch with you and tap into the wonderful research resources that both of your firms are?
Sure. Karl.Freund at Cambrian.AI.com with a hyphen, as you pointed out.
Yes.
And come see my website, read my writings on Forbes and elsewhere, and have a great holiday.
And Jem at TIRIASresearch.com. Obviously, look for our partnership with NextCurve, with Forbes, with EE Times, EE Journal, and a couple of other publications out there, both in terms of videos, articles, everything else. And look for us at some of the conferences going into 2025, especially if you want to schedule a meeting or a briefing. Let us know.
Yes, you must talk to these gentlemen. They're friggin' awesome. And that is the official designation of these 2 gentlemen. Awesome, as well as their firms. And so thank you again, gentlemen. Love doing this with you. And to the audience, thank you so much for joining us. Please subscribe to our podcast, which will be featured on the Next Curve YouTube channel. Check out the audio version on Buzzsprout, or find us on your favorite podcast platform. Also, subscribe to the Next Curve research portal at www.next-curve.com for the tech and industry insights that matter. We will see you next time.